In this video, we're going to look at how we can find the probability of certain events happening from two-way, what we call frequency tables. All right, so let's jump in and see what that looks like. So first off, before we get into two-way frequency tables, we need to talk about something called bivariate data. And what this is data that consists of pairs of linked numerical observations or frequencies of things in categories. This numerical bivariate data, meaning that it has a relationship between two different things, can be presented as a set of ordered pairs, like an x, y, as a table, and this is what we're going to focus on today, or as a graph on the coordinate plane. An example of bivariate data would be categorizing students in two ways. The first would be looking at what grade are they in, and then the other would be how much time they spend on homework each night. Okay, so do you see how we'd be comparing those two things? The grade they're in, and then the amount of time they spend on homework. And from there, we can make some inferences about grade level and the time spent on homework. Now, when we have these things, what we're going to do is we're going to take these two sets of information and we're going to create frequency tables, because they are a common way to display this bivariate data. Let's look at what exactly is a frequency table. Here we have a frequency table, and what it's doing is it's displaying the results of a survey that examined the relationships between gender and how much they play video games. We notice that the value in each cell will represent how often, also known as the frequency, that the row category and the column categories intersect. We have row categories like boys and girls, and column categories like play daily and play occasionally. And what this table does is it allows us to see how often those two categories intersect with each other. So let's look at an example of really what this means. So the 12 in this set of data represents girls because that's the row it's in. That play, it's in the column play occasionally. And that's how a two-way frequency table works. Now, just a quick tip. If the totals here and here are not already provided, it's a really good idea to find those before trying to answer any probability questions, because you're going to need your totals to be able to find the probabilities. So let's take a look at another step to these frequency tables. In Algebra 1, you looked at probabilities for each cell in the table. So if we looked at a two-way frequency table, we would find the probability of each thing. And when we did that, that was called a relative frequency table, which shows what we call joint and marginal relative frequencies. So basically, each cell's frequency in that table is found into a probability which relates it to the total. We said that we have joint and marginal frequency. Joint relative frequency, those are values in each category divided by the total number of values there. Each cell was considered a success and divided by the total number of possibilities in the chart. It's also known as the probability for that piece of data. And then the marginal relative frequency, these are found by dividing the total row or column by the total number of values. So they're in what we call the margins of the chart, just like a sheet of paper has margins. On the next slide, we'll look more deeply at where joint and marginal frequencies pop up. But these represent the probability of each category being a success. So let's look at what's the difference between a frequency table and a relative frequency table. So in a frequency table, we literally just have, 16 boys play daily, or 12 girls play occasionally. But in the relative frequency table, we have 16 divided by the total of 40 people, and we get 0.40. That is the probability of boys playing daily based off the 40 people we asked. So if we look at this, each one of these values came from taking the value that was in the box dividing it by the total 40, and that's how they got 0.2. And then the same thing for each one of those probabilities there. Now, when we talked about in the previous slide that joint and that marginal relative frequency, the joint relative frequency is where the two categories kind of overlap with each other. So boy overlaps with daily, play daily to get that 16/40 or 0.40. Girl overlaps with play occasionally to get this 0.30. That's our joint frequency. And then the marginal, again, it's in the margins. It's in like this outer portion, just like on a sheet of paper you have margins. It's in the outer portion of the graph. In the frequency table, it represents raw data. To answer probability questions, you would need to set up fractions using the information in the chart. But in a relative frequency table, this represents probability. So the probability is kind of already found for you in relative frequency table. And to answer probability questions for this, you really just need to pull the numbers from the chart. So they both kind of have their usefulness. But let's take a look at this a little closer, because you can actually get percentages from these tables too. So if we were given this original chart right here, that's the original frequency table, where it's just where do they overlap and what are our totals for each category. Then if we divide each of those numbers in the frequency table by the total 40, we end up with our relative frequency table. That's in decimals. And then we can take that and easily convert that into percents to get this final percentage table where we can say, oh, 30% of girls play occasionally, or 20% of boys play occasionally. So you can see how easily you can convert from just a frequency table to a relative frequency table, then converting that to percentages so it's easy to talk about. All right, let's take a look at some example problems here in the next video.